Hello and welcome to the course Remote Sensing for Everyone. So this course will be divided into three parts. The first part is what we'll look at today, which is words and phrases used in remote sensing. So let's begin. The question is, why is it remote sensing for everyone? Why? And the answer is simple: because we use remote sensing in our everyday lives. When you take a photograph with your cell phone, you're using remote sensing. When you take an aerial photo or an aerial video with your drone or your UAV, you're using remote sensing. Even for those who have the latest technology on the iPhones, when you use the laser 3D scanning, that's remote sensing. When you open the Google Earth for navigation, you're using remote sensing because it's based on remote sensing images. But for us, the reason why we are learning remote sensing is because we want to use remote sensing to collect information about the surface of the Earth and use this information to solve problems, monitor objects, and predict different phenomena. So what is remote sensing? Remote sensing involves receiving information about an object or a phenomenon without making physical contact with that target, especially on Earth. So we see that we have two words here. An object. An object can be a material thing that can be seen or touched. For example, your laptop is an object, your phone is an object, but typically in remote sensing, we look at larger things like buildings and roads. And then we have another word, which is phenomenon. A phenomenon is something that is observed to exist or happen. For example, floods, typhoon, tsunami, hurricanes, forest fires, etc. Another definition of remote sensing can be the art and science and technology of observing an object, scene, or phenomenon by an instrument-based techniques. Here we see that we have another word added to the object and phenomenon, which is scene. And the question is, what is a scene? A scene is a specified area or landscape of activity, interest. For example, your grandfather's crop farm or administrative boundary of your city can be considered a scene. We also find that in this definition we have the words art, science, and technology. Remote sensing is referred to as an art because we are applying human skill for interpreting images. So the skill and expertise of a person to visually interpret such images is also part of what is remote sensing. It is also considered as a science because we're using systematic methodology to interpret the images. And then we consider it as a technology because we use this methodology to interpret and analyze objects and the images. So, for example, now we have this image, which is a remote sensing image. Look closely at this image and try to think what you observe in this image, what is observed in this image. As you can see, there are black boxes all over this image. What is this image trying to show, or what is it trying to find? Take a minute and try to figure out what it is. I'll give you a clue. These are objects that are being identified in the image. What objects are these? As you can see, these are buildings. All these are buildings that are being identified, being detected by the remote sensing image. So we can use this to count buildings, to enumerate the number of buildings in an area. First, we need to detect them, and then we can use it. We can create an algorithm to count these buildings. Similarly, we have this image. Now we see in this image to your right, we see small boxes. Also take a minute, pause the video and try to figure out what is in these green boxes. It should be easy to tell. Just take a minute and try to figure out what this image is trying to find. Yes, as you can see, these are vehicles parked on the road. Some of them are probably moving. So this image is trying to identify vehicles. So similarly, we can also use different algorithms to count the number of vehicles in the scene. But then on your right, you have another image. In this image, it's kind of hard to tell. Even if you take a minute, if you have no experience with this type of image, it will be difficult for you to tell what is shown in this image. This is a SAR image. It's a type of remote sensing image which shows information that is not easily identifiable by our eyes, by human perception or by human eyes. But then, like I mentioned earlier, remote sensing is an art, and it involves human skill and expertise to be able to interpret images. So in this image, these yellow dots are cars. And for someone who has worked with SAR remote sensing images for a long time, they'll be able to tell that these are cars. In the next image, we have a phenomenon. What do you call this type of phenomenon? This is a hurricane or a typhoon or a cyclone, tropical storm. Hurricanes, cyclones, and typhoons are the same. The only difference is where they originate. For example, typhoons originate from the Pacific Ocean, while cyclones originate from the Indian Ocean, and hurricanes originate from the Atlantic Ocean. So this type of phenomenon, we can use remote sensing to try and track how the trajectory of this cyclone or this typhoon. So usually after a typhoon, we see that floods occur, and remote sensing becomes important to get information about floods. And the question is, why is it an advantage to use remote sensing to get information in a flooded area? And the answer is simple. It's simple. It's a no-brainer. You cannot go on sites when there's a flood because it's difficult to navigate. So remote sensing becomes handy in such situations. You can get information while you're not on the scene. While the place is flooded, you don't need to get a boat to access these difficult to access areas. You just get that information using remote sensing. So now we know what remote sensing is. Let's try to break it down further. We have two words, remote and sensing. What do these two words mean when separated? Remote is because the target is not near, it's far away, and you don't need to make physical contact with it, so it's remote. So because the observation is done at a distance without physical contact with the object or phenomenon, so it's referred to as remote. Also, sensing involves the detection of energy such as light or any other form of energy in the electromagnetic spectrum. So later we will try to differentiate the difference between images that are captured from light and images from other parts of the electromagnetic spectrum. Like I mentioned earlier, conventional cameras can be examples of a remote sensor. Like your phone can be a good example for remote sensing. So we see that in remote sensing, there are words that are sometimes linked to remote sensing. For example, Earth observation. Earth observation is gathering information about the physical, chemical, biological, geometrical properties of the Earth. Physical, you see these 5 words. Physical refers to anything that can be touched or seen. For example, the targets that we mentioned earlier, the buildings, the cars, etc. And then chemical can be any substance consisting of matter, which includes solids, liquids, gas, etc. And then biological refers to living organisms, flora and fauna. Flora and fauna refers to plants and animals. As you can see here, we can get information about animals, information about plants, agriculture, etc. And then geometrical is related to the shape of something. For example, shape of a building. For you to be able to identify a building, you have to know the shape of that building, and that is its geometrical properties. So getting in this information can be done remotely using remote sensing, but that doesn't necessarily mean that some information in Earth observation, some information doesn't need remote sensing. You can use other methods to observe the Earth. So this is where we differentiate Earth observation and remote sensing. Remote sensing, like we mentioned, you're getting information without making physical contact with a thing. While Earth observation, we use different methods. We use remote sensing, you can be in contact, different methods. So the result is in Earth observation, we are mapping, monitoring, and also forecasting. So mapping involves recording in detail the spatial distribution of something. For example, objects like buildings, phenomenon, floods, etc. And then monitoring, it is to observe or to check something over a period of time. Like you want to see how the floods are progressing or how a certain cyclone, the trajectory, how it has progressed over time. And then forecasting, it is trying to predict a future event, like try to predict urban growth, for example, by looking at how the urban areas are growing, or try to predict when floods are going to occur. You can use Earth observation for these purposes. Another word that is very important in remote sensing is photogrammetry. Photogrammetry is the science and technique of making measurements on photos and converting these measurements into quantities which are meaningful. Photogrammetry is the science and technology of obtaining reliable information about physical objects and the environment through the process of recording, measuring, interpreting images. So this image can either be photographic image or electromagnetic image. And like we mentioned earlier, that photographic means images that are captured using light, and then electromagnetic image can be an image that can use any other part of the electromagnetic spectrum. So we said we are recording, which means to register or write down a piece of information from an instrument. And then measuring is the process of calculating something. And then interpreting is to explain the meaning of that information. So we try to explain what we have recorded and calculated. Okay, so now that we have all these definitions, we now know what is remote sensing. And we say that remote sensing is getting information without being in physical contact with something. Now the question is, how does that work? How is it possible that we get information about something without having been in contact with that thing? Try to think, how is this possible? We haven't been in contact with that thing, but we are able to get to know its shape, we're able to know its properties, we're able to know its characteristics. How is that possible? What kind of technology is used to make this possible? So we get information about this scene. How is it possible? And the answer is simple. We do this using electromagnetic energy. You know that energy comes in many different forms. It can be kinetic, potential, chemical, acoustic, electromagnetic energy, or radiant energy, which is what we are interested in when we do remote sensing. Electromagnetic energy. What is it? Electromagnetic energy travels in the form of electromagnetic waves. And electromagnetic waves are a result of vibrations that occur between the electric field and the magnetic field. So it is composed of oscillating electric and magnetic fields, and this is why it is referred to as electromagnetic. So these waves have different properties or different characteristics. The first one is the amplitude, which is the peak value, which we find here, the peak value of a wave, or the height of the wave measured between what we call the trough and the crest. And then we also have the wavelength. This wavelength, which is the distance the energy travels from a moment of maximum energy until it reaches another moment of maximum energy. And then we have the frequency, the number of cycles of the wave that occur per given second. So frequency can either be a high frequency or low frequency. And we find that if it is high frequency, usually it is short waves, and low frequency is long wave, which is very important to know in remote sensing. Why is it important? It is important because the wavelength or the frequency determines where a wave is placed, or certain electromagnetic energy is placed within the electromagnetic spectrum, which refers to a total range of wavelength of EM radiation, which extends from the gamma rays to the radio waves. In remote sensing, we are more worried about areas that are very useful to remote sensing. And we have the visible portion, the infrared portion, and the microwave. The visible portion of the spectrum is the portion of the electromagnetic spectrum that is visible to the human eye. So this is the area that is mostly used because the human eye is sensitive to this portion, this visible portion, and it is referred to as the visible portion of the electromagnetic spectrum. Electromagnetic radium in this range is called visible light, or just simply light, usually defined as having wavelengths in the range of 0.4 to 0.7 micrometers. And then we have the infrared region, which can be divided into two categories based on their radiation properties. That's the reflected infrared and the emitted or thermal infrared. This one stretches from 0.7 micrometers to 100 micrometers. And then we also have the thermal infrared, essentially the radiation that is emitted from the Earth's surface in the form of heat, ranging from 3 micrometers to 100 micrometers. Now, recently we find that the microwave part has become of interest to the remote sensing community because they're able to do observations in almost all weather conditions, and they are not restricted by the presence of light, the presence or absence of light. So they are weather independent and light independent. And this is longer wavelength in the electromagnetic spectrum, measuring between 1 millimeter to 1 meter. Okay, so now the EM radiation has different interactions that occurs with the atmosphere. That is, when the radiation is sent from the energy source, and when it interacts with the object and reflected to the sensor. There are different interactions that occur during this transmission, and we find that with remote sensing, these interactions are very important to the kind of information that is going to be received by the sensor. So what is radiation? Radiation is the emission or transmission of energy in the form of waves or particles through space or through a material medium. And then interaction is a particular way that the electromagnetic waves affect one another and how they are affected by different particles in the atmosphere or on the object. And then transmission is the process of passing of energy through a medium or material. The remote sensing wavelengths that are not absorbed but absorbed by the atmosphere are useful for remote sensing of the Earth's surface. And then we also have the word scatter, which means to separate something into different directions. Usually occurs when energy is redirected from its original path by different aerosols or particles or molecules in the atmosphere. An interesting word here is aerosol. An aerosol is an abbreviation of aerosolution, which is a suspension of fine solid particles or liquid droplets in air or another gas. Aerosols can be natural or man-made. Examples of natural aerosols are fog, mist, dust, forest, etc. Forest exudates, etc. And then we also have absorption that takes place. Gases or aerosols in the atmosphere take in the energy. That is, absorption means taking in. So when we say that energy has been absorbed, we mean that energy has been taken in. So in the atmosphere, there are aerosols that absorb, and also the target on the ground, there are objects that absorb some energy. And then reflection takes place when the energy bounces off the target and is redirected away from the target, most preferably to the sensor. Yeah, so this is basically the remote sensing process and the interactions that occur during the remote sensing process. Now we have additional words, which I can say give us a conclusion that the words that summarize what we've been talking about today. So we have the target, which can be an object, scene, or phenomenon. For example, buildings and cars, and we try to get information about that target by observing it, which is the observation, the process of looking closely or monitoring something. And then in that observation, we try to detect exactly what we want. That is the perception that something has occurred or something exists. For example, we want to detect the buildings. We want to detect that these buildings exist. But how do we know that? We look at the characteristics of those buildings, which is the feature or quality that they have. So the quality or feature of an object is what we look at for us to be able to detect the things that we are observing, the target that we are observing. And then the characteristic is the same as the property, which is a feature or quality belonging typically to an object, scene, or phenomenon. So property and characteristics are the same thing that we look at and try to, if you are going to be training an algorithm, they have to be able to identify that characteristic of the building or that property of the building. And then we have other words like infrastructure, which is physical and organizational structures and facilities like buildings, roads, power supplies, etc. And then chlorophyll can be an important property found in plants, which is very useful in remote sensing when we try to identify vegetation. For more words, we have the platform, the remote sensing platform, which is a hardware that serves as a foundation or base. Typically, this hardware is a foundation or base for our sensor. So this is where we mount our sensor so that we are able to get information. And then platforms can be either ground-based, air-based, or space-based sensors. And then a sensor is a device that detects and responds to some type of input from the physical environment. So when the energy is redirected, it goes to the sensor, and the sensor is able to detect the reflected energy. But then again, sensor is a very broad term because we can use our eyes as a sensor, we can use our ears as a sensor to listen to sound. We can use different types of sensors. But specific to remote sensing, antennas are the type of sensors that are used to either transmit or receive signals. And then we also have an aerial, which is also a type of sensor, which detects signals or transmits signals. However, the word aerial can be used as an adjective, which means something that is happening in the air. Like, for example, taking an aerial photograph, which is an area, which is a photograph of the surface of the earth. Another important word is resolution, which is the smallest interval measurable by an instrument. And then classification, dividing something into different categories. So in remote sensing, classification is important because we use it for different purposes to try and identify different land uses, or to try and identify different types of objects by looking at their properties, and we classify objects or scenes that have the same properties together. We put them in the same class. And this is very important for us to be able to look at different phenomenon and different objects. So basically, these are some of the words and phrases that are important and used in remote sensing. And here is a glossary summary of some of the words with the Chinese translation. There are many more remote sensing words that you come across, and I'm sure we'll have another course which will have more words, and as we take more classes, we will make new words, and then we just put them together, and then we create another class, find